the table from the very beginning, in which we only put -1 to 1 and nothing else. Of course, f prime of x, and of course, f of x. Like before, we have to find critical numbers. How do we find critical numbers for a function? What do I have to do to find the critical numbers for a function? What do I need to determine?
Does it be greater than 0?
Not yet. We need something else before we discuss that. That's okay. So what do I have to find before I find the sign? I need to find the critical number. How do I find them? Remember, they come from two sources. From f prime being 0 or from f prime being undefined. So I have, when the function is defined. So I have to find f prime. That's my starting point. Can anyone differentiate the function for us?
3x squared.
Excellent.
Minus 4x cubed.
Yes, awesome. Of course, I'm going to cross this out. Why am I crossing this out? How come that this function cannot be undefined?
A polynomial.
Of course, it's a polynomial. Very good. So I can only solve this equation, which is 3x squared minus 4x cubed equals 0. Do not simplify by x or x squared. You have to pull it out. So 3 minus 4x equals 0. Again, what is the degree of this polynomial? Because if you say 5, then we have to find 5 solutions. If you say 2, then we have to find 2 solutions. What is the degree?
3.
Yes, so I have to find 3 solutions. Yes, you can use the graphing calculator to determine them if you want, but this is too easy. 2 solutions are the same. X equals x equals
0.
Yes, 2 of them. Good. And the other one is 3 minus 4x. I move 3 to the other side, and it's x equals 3/4. So I have 2 critical numbers. You can say 3, but 2 are the same. Exactly 3, but 2 are identical. And 3/4. So let's see if they fit in the given interval. Yes, 0 is here. 3 over 4 is 0.75. Yes, it's here. So I have 0 and I have 0. That's how we determine these numbers, by setting the first derivative equal to 0. Awesome. Now, exactly as you said, I need to find the sign of the derivative. So here's a derivative. When I plug in -1, this is 3, but this is +4, because -1 cubed will be negative, times -4 will be positive, so this is positive. I'm going to plug in, this is difficult, between 0 and 0.75. So I'm going to plug in, let's say, 0.2. 3, so we can do this quickly with a calculator, so I don't confuse you. So I have 3 multiplied by 0.2 squared, 3 multiplied by 0.2 squared minus 4 multiplied by 0.2 to the third. And I got still positive. Good. And now let's plug in 1. 3 minus 4, negative. Good. So then, now we draw conclusions. Not before. We take this function and we plug in -1 and get a number here, 0 and get a number here, which is clear, there is 0. I don't need to calculate that with a calculator. 3/4, and I put a number here. And 1 minus 1 is 0 also. So I need to plug in the graphing calculator. In this function, I need to plug in -1. Not a big deal. This is negative and this is negative because this is still positive. So this will be -2. This is the only one that I need a calculator for, basically. So I have 3/4 to the third power 3 divided by 4 to the third power minus 3 divided by 4 to the fourth power. And I got 0.11. Got it. At this moment, as you know, we need to make sure that these two rows work well together. If they don't work well together, something is wrong and there is an error somewhere. I have to find it. So let's try. From -2 to 0, what does the function do? From -2 to 0. The function,
Increases.
yes, is that supported by the sign of the first derivative?
Yes.
Yes. From 0, I know, to 0.11, what does the function do?
Increases.
Perfect. Is that supported by the sign of the first derivative?
Yes.
And then from 0.11 back to 0, what does the function do?
Decreases.
Yes, and it's supported by the sign of the first derivative. So now we have to establish what's going on. And you can say it's kind of difficult to figure it out. We'll do it together right here on the side. I'm not graphing the function. I'm just saying this first point is at -2. The next point is up at 0. The next one is further up at 0.11. And the next one is back down to 0. So something like this. Now I have to identify each point. Let's start with this point. -1, -2. What will this be? I'm not graphing the function. I'm just giving you an idea. What type of point will this be?
Absolute minimum.
Absolutely. Can it be relative?
No.
No, because it's at the endpoint of the interval. Awesome. What about 0, 0? This point. Remember, the derivative does not change sign.
It's nothing.
Nothing. Nothing. Nothing. Perfect. What about this one? 3/4, 0.11.
Relative max.
And also
Absolute.
and absolute max. Perfect. Last one. This one. 1, 0.
That's nothing.
Nothing. And it cannot be relative because it's at the endpoint of the interval. Awesome. That's it. That's all we need to do to study the absolute max and min for a function on a closed interval. Is this okay? Can we move on to a word problem? Do you think we need more examples?
A quick question. What is that on the last 0? What is that writing that is written next to it?
For this one, absolute minimum.
No, all the way on the right, please.
Here,
Yeah.
relative max as well as absolute max.
Okay.
Both of them for 3/4, 0.11. So these are both for this point, 3/4, 0.11. Relative max as well as absolute max. Is that okay?
Yeah.
Sorry about that. Do you think we need another example, or is this good enough? Anyone? Can we move on to a word problem? Okay, well, no one said anything. Maybe you will find other problems for next time, or you find something now. That's up to you. So So page 5. Good. So let's say monthly productivity. An employee's monthly productivity, M in number of units produced. So this is 49. M units produced is found to be a function of T, the number of years of employment. T in years. Fine. And the function is M of T equals negative 2T squared plus 100T plus 180. And they are giving us the closed interval. T is between 0 and 40. Find the maximum productivity and the year in which it is achieved. Awesome. Exactly what we just did. How do I start? What do I have to find first? Anyone?
Critical numbers.
Yes. How do I find critical numbers? Awesome. What do I need to do? I need to find what do I need to determine first to find the critical numbers?
The derivative equals
Yes.
0.
Yes. So m prime of t, first of all, and then it's 0 or undefined. Can anyone differentiate it for us?
Negative 4t plus 100.
Excellent. And of course, this cannot be undefined, but it could be 0. If it is 0, then I move 100, becomes negative, and I divide by negative 4, so I get t equals 25. Now I have to study the sign, left and right, and this is the derivative. Please plug in 0 in here and tell me the sign. And please plug in 40 in here and give me the sign. I don't need a number, I only need the sign. So when we plug in 0, we get?
100.
Yes, so the sign is positive. When we plug in 40, what is the sign here?
Negative.
Yes, it is negative because this will be a negative 160 plus 100. Awesome. Good. At this point, we know the conclusion here. We know that, but we have to plug in 0, we have to plug in 25, and we have to plug in 40 in the function. So when I plug in 0, that's easy. But then I have to plug in 25, and then I have to plug in 40. That's mandatory before we draw a conclusion. No problem. That's easy. I'll punch in y equals, I clear everything, and I have negative 2t squared, and then plus 100t, and then plus 180, and I go second in table, and I want 25, and I want 40. That's all. So for 25, I find 1430. And for 40, I have 980. So what is the year of the maximum productivity?
$25.
Yes. So obviously from 140 to 1430, obviously it's increasing, and that's supported by the sign. And the same thing here, going down. So one more second. What was the other one? 980. Why did I put that dot? I have no idea. There's no dot there. Okay, so this is definitely the relative max as well as the absolute max. No question about it. So relative plus absolute max. But I also would like to identify 0, 180 and 40, 980. So remember the numbers are something like this. 180 up to 1430 and down to 980. Something like this. I'm not graphing the function, I'm giving you the idea. So this is the absolute and relative maximum, no question about it. 25 year of experience. Now, what is 0, 180? This point.
The relative min.
It cannot be relative at the endpoint of the interval,
Oh,
but it's the absolute.
okay.
I agree. Absolute minimum. What about this one?
And that's nothing.
Nothing indeed. Nothing, because it's at the endpoint of the interval. It cannot be relative, and it's cannot be higher. There is another one higher and another one lower, so it cannot be anything when it comes to the absolute. Awesome, great job. Okay, the next section is basically the same thing. It's optimization, meaning finding max min for different functions. So let's see what we want to work on. They are all the same thing, critical number, all the same steps. We may have to find the function. The function may not be given to us. So this is 328, 328. So let's see what we are interested in.